Thanks for inviting me here. It's really wonderful to be a part of this initiative. I'm not going to speak much about myself, but rather I'm going to be talking about. So I was tasked with talking about restoring grassland mosaics that have been invaded by nitrogen-fixing woody plants. And on the bright side, I think most of the points that I wanted to make have already been made in the previous session. So I can just go through it very quickly. I don't need to elaborate on many of these points much. So the idea is to go from something like this, where you can see a bright Oshola patch surrounded by, invasive wattle, to something sort of, well, if you get thinking wishfully, we can say we want to be heading in this direction. But as the point was made in the previous session, I mean, are we even going to get close to this? That's a different debate. But the point that we're trying to make is let's at least try to head in this direction to, restore some of these grasslands. And I'm going to be focusing on talking about three invasives. Again, this has already been mentioned earlier. And these are the three players that are a bit of a problem at the high elevation montane grasslands. They're Acacia munzii, Ulex, and Cytisus. And the thing about all these three species is they are nitrogen fixers, right? They're some of the few nitrogen fixers in a system that's actually not dominated by nitrogen fixing plants. And because of their ability to fix nitrogen, they have fundamental impacts on the ecosystem. And these are things that we need to consider when we're thinking about restoring the systems to back to how they were, right? So we've been working in the system for quite a while, and Atul has talked about what actually maintains this mosaic. So I'm very quickly going to talk about, what our studies have told us about the impacts that these invasives are having on this ecosystem, right? And it's the work of many students, collaborators from Ferrell, from Atri, and so on. So I'm just going to highlight the main findings of our studies over the years. The first thing is invasive plants reduce native species diversity. So if you look at an invaded patch and adjacent grassland, there are fewer species in the invaded patch compared to the grassland. And not only that, there's a change in the species composition. As Vasant was mentioning in the earlier session, if you look, most of the grasses that we have in these systems are C4 grasses. They employ the C4 photosynthetic pathway, which means they're not shade tolerant. So when you have these woody species invading, you have a different set of species, grasses that come in the understory. Many of them are actually exotic, like Vulpia and so on. And many of them are C3. So they have a fundamentally different photosynthetic pathway. So in some ways, you're changing the entire physiology of how the system is operating, right? The other thing is they tend to homogenize plant composition. So if you look at grassland patches, they tend to be much more different from one another compared to these invaded grasslands. So invaded patches tend to be much more similar when compared to native grasslands, right? So like I said, these are nitrogen fixing plants, and essentially what they've been doing, they have changed the nitrogen availability in the system. So there's much more nitrogen available now in the soils in these invaded patches, and there's much nitrogen cycling at a much faster rate in these invaded patches, right? And not only that, they have also changed the hydrology of the system very, very fundamentally. This is work from Atri and Ferrell and our group. They've altered the hydrological cycle. So if you look at water flow out of catchments that are invaded by wattle, particularly following extreme events, you see much more water flowing out from invaded patches when compared to native patches. Native patches, there's less water flowing out following extreme events, and the water flow is also maintained much longer into the dry season. Right. And also, because you have more nitrogen cycling through the system, if you look at the water flowing out of these invaded patches, there's actually much more nitrate in the streams, right? So this nitrate is going downstream, and it's going to eutrophy water bodies downstream, right? And finally, they also change the fire regimes in these places. If you look at satellite images and look at the fire scars, they tend to be much more intense in areas that have been invaded when compared to the grasslands, right? So all of these means they're fundamentally changing the ecology of these ecosystems, and so we need to deal with that. So what actually allows these invasives to invade these grasslands? Again, this point has already been made by Arundhati and others in the previous session. For one, as Atul pointed out, they have the ability to tolerate frost and freezing temperatures, which surprisingly the native woody species do not seem to have, except for probably rhododendron. And they also have very high fecundity. They produce a lot of seeds, right? And these seeds are viable for a very long time, and they get dispersed. And as Atul showed, future warmer temperatures are likely to exacerbate this invasion. So under warmer temperatures, we're going to have much more invasion by all of these species. And so restoration of these invaded grasslands is a priority, right? So I'm not going to be, so this restoration is just work that's starting. We really don't have much experience restoring these grasslands particularly, or any grasslands globally for that matter. Grasslands are very, very hard to restore. It's much easier to restore forests, and there's a lot of examples of successful restoration of forests. There are very, very few examples of successful restoration of grasslands globally, right? So this is a challenge that, we need to appreciate and tackle it head on. So I'm going to give some just start off by giving some very simple messages that these apply to any restoration program. And I know there are a lot of really wonderful restoration practitioners here who will be able to give many other sort of key take-home messages that we need to keep in mind when we're thinking about these restoration programs. And the first is this: restoration is a long-term activity. It's not a one-off thing that it's going to get done in a year. We need to be in it for the long term, right? And so we need to be thinking long-term about restoration. It requires continued commitment, both in terms of manpower as well as funding, right? Restoration efforts should aim to enhance biodiversity. Very often, if you're limited by our ability to actually regenerate these species, then we tend to plant fewer species and so on and so forth. And that's a bad idea. And particularly applies to restoring grasslands because, regenerating many of these grasses is particularly problematic, right? And that's something I'll talk about in a little bit. I personally think it's better to set small-scale, achievable goals rather than try to do everything at the same time. And this is very key. It's been mentioned over and over and over again over the last couple of days, and I'm sure it'll be mentioned tomorrow too. Building community partnerships, especially the local communities, and by local we mean, the indigenous communities who are the actual locals here. We need partnership between the Forest Department, NGOs, researchers, and so on and so forth. So, like for example, the Forest Department has, the DFO mentioned in the previous, you auction this. You're out to clear the, people clear the wattle, but what happens next is a point that was also made as a question. Who is going to be responsible for dealing with it after that? The Forest Department has some money, but do they have enough manpower? Or maybe it's something that, collaboration with NGOs and researchers can help actually take the restoration to the next level. Yeah. So these are some really broad comments. And this is one very, very important thing. Well-designed monitoring programs are very, very key, right? Are we monitoring these areas that we are restoring? Once we clear it, do we have systematic ways by which we are actually tracking the trajectory of restoration year by year? And if we do that, only then can we course correct, right? So this is very key. And I think this is something that we need to talk about. Maybe the Forest Department is already doing it. I don't know, but it's something to keep in mind. Yeah. So what are the site-specific considerations, right? So like I said, clearing of invasives is just the start. It's not the end of the restoration process. There's again a point that's being made. Everybody recognizes it, but it's good to keep this in mind. This is also a point that was made. I think Arundhati made it, and then Robbins made it, and different people have made it. We need to prioritize. It may be good to actually prioritize restoring the invasion front first, and then you go to the medium, and the highly invaded areas for multiple reasons. Because when you start off with the invasion front, maybe you learn some things about how to actually deal with this, so that when you actually go to the heavily invaded areas, you have a little bit more knowledge about how to actually restore these ecosystems. A couple of other things, and this we talked about scaling up, and this is very key. I don't know, from my experience, we've had a lot of trouble germinating many of the native seeds of grasses. We've been able to grow them from cuttings and tillers and so on. And I don't know, other people here with nurseries will have a better idea of this. If you're not able to generate from seed and you have to go from cuttings, then it just changes the game entirely, right? You need nurseries and you need stocks. And again, this is a point that's been made multiple times. So we need establishing grassland nurseries, very critical to restoring its scale. Here's the thing, I think there's a critical need for research to identify uh, best practices of restoration. So, for example, like I said, invasion by these species has increased nitrogen levels in the system. So these are fertile. There's much more nitrogen here, which is fertile for secondary invasions. This is a point that's already been made, right? When you have more nitrogen, it favors the invasive species. So you have a whole bunch of secondary invasions. So one of the key things here is how do you actually reduce the nitrogen levels in these systems? So do you keep harvesting it for a few years so that you remove nitrogen from the system? Or this is one thing I think is very key that we need to actually think about before dismissing it, is the role of prescribed fire in actually managing this, right? Everybody is anti-fire. I'm a grassland ecologist, and we know fire has been burning these things for millions of years. We know all of these grasses are fire adapted, and uh, and I think using fire maybe or actually having experiments to evaluate the role of fire, because we know that fire actually stimulates germination of many of these invasives like wattle and so on. But we also know they have a very large seed bank, right? So you want to get rid of that seed bank. If not, if they're going to be germinating slowly year on year. So might it make sense to actually just burn it for the first 2 to 3 years so that you stimulate the seeds to germinate, and that way you're actually reducing the seed bank, right? So that your efforts become better over time. We don't know the answer to that question, but it's something I think we need sort of simple experiments to actually test the utility of tools such as prescribed fire. So yeah, and like I said, most of the points have already been made, so I'm not going to belabor that much. But yeah, I think I'll stop it at that and let others talk. Thank you.